Hello students, today we will study numerical methods. Numerical methods provide various techniques to find approximate solution of difficult problems using simple operations. Now we have two types of equation. One is algebraic equation and other is transcendental equation. And equations involving the terms like x squared and so on are known as algebraic equations. And equations containing the terms like e raised to x, log x, sin x, tan x, etc. are known as transcendental equation. Now, numerical method use the iteration process, which is a repetitive type of process. In each step, the result of previous step is used and the process is carried out until desired accuracy is obtained. The value obtained in succeeding step is always better than the value of the preceding step. Now, if you consider the equation f of x equals to 0 is a real valued continuous function of the real variable x, we have the following fundamental property. If there exist two values a and b such that f of x has opposite sign, that is f of a less than 0 and f of a greater than 0, such that f of a into f of b is less than 0, then there always exists at least one real root in the interval a comma b. Now, if the values of a and b of x are nearer enough, then the numerical iterative methods will give the real root to the desired accuracy quickly. Now, let us start with the regular falsy method, or it is also known as method of false position. The formula is given by x equals to a into f of b minus b into f of a divided by f of b minus f of a. Consider the first example. To find real root of the equation x cube minus 2x minus 5 equals to 0, correct to 3 decimal places. Let f of x be the given function equals to x cube minus 2x minus 5. Now we have to locate where the root lies for the given function. Therefore, take the values for x as 0, 1, 2, 3 in the function. That is f of 0. Put the value of x as 0 in the function. X cube minus 2x minus 5. So, f of 0 will be equals to minus 5. Now take the value of x as 1 in the function. So f of 1 is minus 6. Take the value of x as 2. Therefore f of 2 is minus 1. And now take f of 3. That is, put the value of x as 3 in the function, which will give you the value as 16. Therefore, now we observe that f of 2 is less than 0 and f of 3 is greater than 0. That is, we use the property f of a into f of b is less than 0 and say that the root lies between 2, 3. Now, to reduce the iteration process, we see at which value the function is closer to 0. That is, at what value of x the function value is closer to 0. So, according to the observation, f of 2, which is minus 1, is closer to 0 than f of 3, which is equals to 16. Therefore, we say that the root lies in the neighborhood of 2. Therefore, now we consider, let x equals to 2.1 and put this in the function. So, f of 2.1, which is equals to 2.1 the whole cube minus 2 into 2.1 minus 5, which will give you the value as 0.061 which is greater than 0. And previously we checked for the value of x where a function is negative, that is f of 2. Therefore, we say that the root lies between 2 and 2.1. So, in the first iteration process, we consider let a is equals to 2, b is equals to 2.1 and respective f of a equals to -1, f of b is equals to 0.061. Now, substitute these values in the formulae, that is the first iteration x1 given by a into f of b minus b into f of a divided by f of b minus f of a. So substitute the values and the answer is 2.0942. That is x1 is given by 2.0942. Now again we have to put this as x value in the function and check what will be a value. So f of 2.0942. Substitute the value of x as 2.0942 in the function and then the calculated value is minus 0.00392, which is negative, that is less than 0. And now we consider the value of the function where we have got positive, that is for 2.1. Therefore, we say that root lies between 2.094 and 2.1. That is, in the second step, we consider a is equals to 2.0942 and b is equals to 2.1. Respectively, f of a is 0.00392 and f of b is 0.061. So now substitute these values in the second step of the iteration and obtain x2. On simplification, x2 obtained, that is, substitute the value of a is 2.0942 into f of b. f of b is 0.061 minus b is 2.1 into f of a is minus 0.00392 divided by f of b 0.061 minus and minus f of a 0.00392. So on simplification the value is 2.09455. Now compare the values of the first iteration and the second iteration. In the first iteration we have got the value x1 is 2.0942 and in second iteration x2 is 2.09455. So according to the observation the values are correct up to 3 decimal places. After decimal we have the values same up to 3 values, that is 2.094. Hence we say the approximate root of the given equation is 2.094, or it is taken to a round up value 2.095. Consider the second example to find the real root of the equation x into log x to the base 10 minus 1.2 equals to 0, correct up to 4 decimal places. So consider a function f of x. Let f of x equals to x into log x to the base 10 minus 1.2. Now again we have to locate where our root lies. Therefore we take various values for x as 1, 2, 3 and see where the root lies. So f of 1, put the value of x as 1 in the function which will give you minus 1.2. Now put f of or x equals to 2 in the function which will give you the value minus 0.6, which is less than 0. Now put x is equals to 3 in the function which will give you 0.23. So according to the observation f of 2 is a negative value and f of 3 is a positive value. Therefore we say the root lies between 2 and 3 and also f of 3, which is equals to 0.23, is closer to 0 than minus 0.6. Hence we say that root lies in the neighborhood of 3. Therefore we take neighborhood points of 3 such as 2.7, 2.8. Put the value of x as 2.7 in the function and it is equals to minus 0.0353, and again put x equals to 2.8 in the function. So the value is plus 0.052. Therefore, f of 2.7 is negative and f of 2.8 is positive. Therefore, we say that the root lies between 2.7 and 2.8. So consider here in the first iteration a as 2.7, b as 2.8 and respective f of a as minus 0.0353 and b as f of b, that is f of b is plus 0.052. Hence in the first iteration use the formula x1 is a into f of b minus b into f of a divided by f of b minus f of a, and then substitute the value. A is 2.7, f of b is 0.052 minus b is 2.8 minus 0.0353 divided by f of b is 0.052 and minus of minus plus 0.0353. On simplification, the value is 2.7404. Now again put this value 2.7404 as x in the function, and the value is equals to, that is f of 2.7404 is equals to minus 0.00021, which is less than 0. Therefore, we take the value of the function where we have got positive, that is at 2.8, and hence we say that the root lies between 2.7404 and 2.8. Now consider a as 2.7404 and b as 2.8, respective f of a as minus 0.00021 and f of b as 0.052. So in the second iteration, now we calculate x2 by using the above values, that is a 2.7404, f of b 0.052 minus and minus, because we have f of a as negative minus of minus plus. So 2.8 into 0.00021 divided by 0.052 minus of minus plus 0.00021, and on simplification the answer is 2.7406. Now you can compare x1 and x2 values. So the values are correct up to 3 decimal places. That is, values are correct up to 2.740. Alright. But the question is asked to obtain the value correct up to 4 decimals. Hence we go for one more iteration. So in the third iteration, now we calculate what is f of 2.7406. That is, put the value of x as 2.7406 in the function, and on calculation we have the value as minus 0.00004, which is negative less than 0. Therefore, now we consider the value where we have got positive and say that the root lies between 2.7406 and 2.8. That is, consider a is equals to 2.7406, b is equals to 2.8, and respective f of a is minus 0.00004 and f of b is 0.052. And now again on substituting the values in the formulae, we obtain x3. x3 obtained is 2.740646. Now we can compare x2 and x3. So x2 is 2.7406 and x3 is 2.740646. So the values are correct up to 3 decimal places, that is 2.7406 and also to 4 decimal places 2.7406. Therefore, we say the required approximate real root, that is equals to 2.7406.